Alright guys, this time around we are looking at adding and subtracting radical expressions. This is actually similar to something you've done in the past. Pretty similar actually. When you're looking at various things, like if I go 3x plus 2x, you should know you can add these two things because the x's are the same. So I could say, oh hey, that's 5x. If I did 3x plus 2y, well, there's nothing you can do here because x's and y's are different. You guys may remember from back when you were doing things like, 7 to the third times 7 to the second would equal 7 to the fifth, where you'd combine the exponents. But if you did something like 7 to the third times 5 to the second, well, you couldn't do anything because your exponents, or your bases, the things that your exponents were attached to, the 7 and the 5, were different. Up here they combined because the 7's are the same. Think this kind of like bases. We're going to do a little bit of simplification, and then we're going to compare our bases. So in this problem example I've pulled up on Delta Math, where your assignment is, I'm going to look at 10 root 108 minus 8 root 3. Right now there is 0 I can do because 108 and 3 are not the same thing. But it says express in simplest radical form. I need to go, can I simplify these? Well, 8 root 3. Root 3, there's no simplifying that. If it was like root 4, I could make a 2, but it's a root 3. You sit there and you go, I got nothing. So that 8 root 3 gets a free pass. It just goes down to the next row. The 10 is going to come on down because, hey, the 10's not doing anything. I'm concerning with this 108 here. You go down the list. Can I divide it by 100? No. By 81? No. By 64? No. By 49? No. 60? You keep going. And for those of you wondering, where am I getting these numbers from? Remember, from the last two videos, these are multiplication table charts. Like, they're perfect squares, just like I have here. 49 is 7 times 7, and 6 times 6 is 36. Well, just like that, in this problem, I have 108. I can divide that by 36. And this is just kind of trial and error with the calculator. Like, I went down in my head doing this till I went, hey, that is actually 36 times 3. Next line. Everything is going to stay more or less the same. I'm going to have that minus 8 root 3. But that 36 can become a 6. So 6 times 10. And then I have that root 3. Well, 6 times 10 is 60. I have 60 root 3. I simplified this minus 8 root 3. Well, guys, whatever root 3 is, if I have 60 of them and then I take away 8 of them, how many are going to be left? Well, 60 minus 8 is 52, and it's root 3 because it was already root 3. That's it. Kind of like if I did 10x minus 3x, I'd say it's 7x. The root 3 is still there, and I do 60 minus 8. I deal with the coefficients on the radicals. Remember, coefficient, the number in front. Radicals are the root symbols. So I'm going to have 52 root 3. So again, 5, 2, click the root button, hit a 3, hit submit. Yes, and I look good. I didn't mess anything up. It's the same thing every time. Now, this first one, I only had to simplify one of the radicals. I simplified what was on this side. To those of you that are looking at this new problem, well, 96 and 24. Neither of these are perfect squares, or they could be simplified as well. So 4 root 96 minus 6 root 24. Well, I like easy things, so I'm going to start on this side. 24 I know is 4 times 6. And 4 is a perfect square. So I'm going to get a 6 times 2 times root 6. This gives me a big hint. Probably these two things, when I simplify them, will have the same radicand, or number under the radical. So this number will probably be the same. So I'm just going to go, hey, what's 96 divided by 6? And when I ask myself that question, I get, well, 16. So, okay, 16, is that a perfect root? Yeah, perfect square. It's a perfect square. It's 4 squared. So that 4 comes down. This 16 turns into a 4. And then I still have that root 6. 4 times 4 is 16 root 6. 6 times 2 is 12 root 6. I go, what's 16 root 6 minus 12 root 6? Well, the coefficients, 16 minus 12, gives me 4. Root 16, wow, for those of you that spotted it, shouldn't have ever happened. It wasn't a 16, I swear. All along, it was a 6. So, boom, 6, 4 root 6. Done. It's not a big deal, but it can lead to some confusion. Same idea this next problem. You can guess where we're going to go. I'm going to have to simplify both of these things. And there's not a lot of variation, so this is going to be the last practice one we do together. So 9 root 150 minus 10 root 96. Well, I just did 96 a minute ago. I was paying attention. I know that 96 is 16 times 6, or going to be 4 root 6. 10 times 4 will be 40 root 6. I still have those minus signs, so this leaves me with, hey, can I divide 150 by 6? This is not guaranteed, but it's a pretty good hint. To those of you that are wondering, yes, 150 can divide by 6. I do out the math and I go, oh, hey, that's 25. Come on, guys. By now you should be going, okay, Pettingill, get with it. We're bored. 25 is obviously 5 squared. 9 times, that's going to be a 5, times my root 6. Oh, look, 45 root 6. Got it, Pettingill. I'm done. 5 root 6. That's it. It's simplifying two different things, and then if they have the same number under the radical, that's called a radicand. So if they have the same number under the radical, like in this case it was a 6, I can just subtract. I leave the root 6. I call it a good day. 5 root 6. Submit answer. And for the inevitable question, what if I get different numbers? Well, what if you do get different numbers? Think about it. Up here, we said like 3x plus 2y didn't do anything. So we need to have the radicands be the same to do anything, or the numbers in the radical. If I told you to do 6 root 2 minus 4 root 3, you know what you do? Nothing. That's it. You're done. Unless I'm handing you a calculator and telling you to do that stuff out, you're done. There's no simplifying that. That's it. You're done. So please be mindful. Take your time. Be careful. It can get tricky, but at the same time, it's just a lot of simple work done out. So those problems that at the end you go, this was hard. Wait, not really. It was just a lot. So it's easy to make a mistake or two. As usual, tutoring. It's a drop-in session on Wednesday. The times are in your messages. Contact me via my school mail or my Google Voice account. Mr. Tibbetts students that are watching this, again, same thing. Contact him through the email or his Google Voice number that's been provided to you. If you haven't been provided with your Google Voice number, just email. We're here for you guys. We can help you get this done. Don't stress it.